Welcome to the Math Record. Today we'll be covering the CCML Geometry Contest 5 2015-2016 Division A. Okay, question 1. The area of a rectangle whose length is triple its width is 100. What's the rectangle's perimeter? So its length. So the area of a rectangle is just a length times width. So whose length is triple its width. So let's say its width is W times its length, which is just 3W, which is triple the width, is equal to 100. So 3W squared is equal to 100. So W is equal to just square root 100 over 3, which is equal to 10 square root 3 over 3. So that's the width. And the length is 3 of that. So the length would technically just be 10 square root 3. So the perimeter would just be 2 of the width times 2 of the length. So that would be 20 square root 3 over 3 plus 20 square root 3, which that's 80 square root 3 over 3 total. Pretty basic. Question 2. In the diagram to the right, okay, so this diagram, JU is equal to 6, UE is equal to 4, and CU is equal to 3 UI. What's the length of CU? Okay, so let's kind of draw this out. Bam, and bam. And we have JU is 6, UC is 4, CU, and let's say UI is X. So CU is 3UI, which is just 3X. So this is just an inscribed angle lines question. So basically, if you multiply opposite sides, they should be equal to each other. So 6 times 4 is 24, is equal to 3x times x, which is 3x squared. So 24 is equal to 3x squared. So divide that gets 8 is equal to x squared. So it will be 2 square root 2 is equal to x. So CU is 3x. So multiply that by 3 to get 6 square root 2. So your answer for number 2 is 6 square root 2. Compute the exact value of cosine 30. Basically, you just need to know your specific right triangles, which is your 30, 60, and 90 degree triangles, and your 45, and 90. These are the only two you need to know. You basically just need to know the side length in relation to the angle. So for the 30, since this is the 30, 60, 90, because this is the 30, we have a 30 degree here. Sorry. 60 and 90. And let's say this is side length x, right? So the opposite side of the 30 is x over 2. And the opposite side of the 60 is x square root 3 all over 2. So cosine of 30 right here is the adjacent side, so which is x square root 3 over 2, over the hypotenuse, which is x, which simplifies to just x square root 3 over 2. It's just something you need to know. What's the area of a regular hexagon with side length 6? Well, a regular hexagon is basically, you have a hexagon which is 6-sided, and it's regular, so all the side lengths are the same, basically, right, etc. So now, put a point in there, and you make these triangles. These triangles are all basically the equilateral, because if this is the same thing, right, and there's 6 triangles, and this is 360 degrees in total, that means each of them is 60 degrees. Since this is 60 degrees, right, and you have this side length, and this side length is the same technically, then this is also 60 and 60. But you can also do the calculations inside, which is just to calculate the interior angle of a shape. It's just x, which is the amount of side length. Sorry, it's 180 times x, the amount of side length. So there's 6 minus 2 divided by x. So x is 6 because it's 6 side length. The number of sides is 6, not the side length is 6. So 180 times 4 divided by 6 is 120. Since this line kind of bisects it, technically 120 is 60. So this is 60 here and this is 60 here. So since this is 60 and this is 60, this also has to be 60. So it's equilateral. So that tells me that basically this, and this are exactly the same side. So all these are exactly the same. And just to save time, if the area to get a equilateral triangle is x squared square root 3 divided by 4. If you could just memorize this is the area of an equilateral triangle, basically. So if x is the side length, so if that's just one for one equilateral triangle, just multiply by 6 to get the entire area. So you have 6, x is 6 because the side length is 6. So we have 36 square root 3 divided by 4, which is 9 square root 3 times 6, which is 9 times 6 is 54. So you have 54 square root 3. So the answer for 4 is 54 square root 3. It's pretty easy to prove anyways. Like, you have an equilateral triangle, right? As I said before with the 30, 60, and 90 degrees, right? You have x over here. Then this is x over 2, and this is x... Oh, sorry. I wrote it the wrong way. This is 60, and this is 30. This would be 30, and this is 60. Because that's the height. So this is x. This is x square root 3 divided by 2, and this is x over 2. So the area is just base times height. So it's just x times x over 2 times x squared 3 over 2, so x squared 3 over 4. And then since that's the area of just this triangle, and then well, you have to divide by 2 to get so you have 4 over 8. So divide by 4, divide by 4 and then divide by 2 is 8. But then you have to multiply 2 because you want to get the area of this also, because you only got the area of this. So you multiply 2, so they kind of just cancel out, so you get x squared 3 over 4. It's good to know just to memorize, because it's faster instead of just wasting your time trying to like prove the area all over that's using it again and again and again. Okay, question 5. In triangle WET, angle E is 90. So you have a right triangle, and you have E, so WET. Okay, and EW is 12, and cosine of W is 4 over 7. So basically you already got 12, so let's call this the hypotenuse. So 12 all over the hypotenuse is cosine of W is just 12 over the H. So W is 4 over 7. So if you multiply 4 by 3, that gets 12. So 7 has multiplied by 3 is 21, so H has to be 21. So that's what it tells me. So this is 21. What is the area of WET? So we already got this, so we could use the Pythagorean theorem, which tells us that 12 squared, let's call this A, plus A squared is equal to 21 squared. So using your calculator, you have 21 squared minus 12 squared, and then you square root it. Actually, which is just 3 square root 33, basically. And which is A. So to get the area, it's just 3 square root 33 times 12 times a half. So that would just be 12 times a half is just 6. 6 times 3 square root 33 is just 18 square root 33. So that's your area. Okay. Problem 6 to 8. The shapes are constructed so that each subsequent layer consists of a solid layer of unit cubes. For example, shape 2 has 1 cube in the top and 4 cubes in the second layer. One of it was just hidden, which is in the back. And the first 3 steps in the sequences are shown. So you see it. So you have a 1 by 1, and then a 1, and then 2 by 2, and then 1, and a 2 by 2, and then a 3 by 3, basically. 6. Compute the surface area of shape 3, so of this shape. So technically, what we're gonna do is that we're gonna look at it in 6 different sides. We're gonna look at it from the top, the top, right? If you're looking from if you're like place yourself on top of the shape and you're looking down on it, so that's gonna be the top. So you're gonna look at it from the top, the bottom, the left, the right, and the back right and the back left, basically. So you're just gonna look at those. So if you're looking for the top, you just have the one here, 2, 3, 4, 5, 6, 7, 8, 9, which makes sense because it's just 9. Even if you move it up, like it's not gonna really change it. So it's gonna be 9 on the top. plus the bottom is also 9 because it's just a 9 by 9, a 3 by 3, which is 3 times 3 is 9. If you look at it from the right, you're just gonna have a 1, 2, 3, 4, 5, 6. So you're only gonna have 6. And the same thing with the left, which is 1, 2, 3, 4, 5, 6. And if you look from the back, if you kind of think about it, you only have like a 1 by 1, a 2 by 2, and a 3 by 3. So 1 by 1, 2 by 2 by 3 by 3. Then you just gonna have that 1, that 2, and that 3. So 1 plus 2 plus 3 is 6. And that's the same case for the back right, which is also a 1 by 1, a 2 by 2, and a 3 by 3. So it's just 1 plus a 2 plus a 3, which is 6. So that's 18 plus 12 plus another 12. I'm just combining them together. 9 times 18, 6 plus 6 is 12, 6 plus 6 is 12. So that's 30 and that's 42. So the first surface area for number 6 for shape 3 is 42. Okay. 7. Compute the volume of shape 8. So if you think about it, yes, shape 1, right? Shape 1 has an area of 1. Shape 2 has 1, 2, 3, 4, 5, has an area of 5. Shape 3 has an area of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You have 14. If you think about it, it's a 1 by 1, and then you add a 2 by 2, and then you add a 3 by 3. So a 2 by 2 is a 4, a 3 by 3 is a 9, right? So that's a 4, that's a 9. And then you're going to add a 5 by 5, a 6 by 6, a 7 by 7, etc. So if you add that's a 2 and that's a 3. A 4 by 4 is a 16, so this is a 30. And then you're going to add a 5 by 5, which is a 25, so that will be a 55. So you could kind of just do the exact same thing each time. You get a 36. So that's 8 and 91. That's a 6. And then a 7 would be if you add a 49. So because that's a 7 squared. So a 7 squared, 49, plus 91 is equal to 150. So that's a 49. And now you're going to add a 8 by 8, which is 64. So 64 plus 150 is equal... Oh, sorry. 140. Oh, oops. Sorry about that. That's 140, not 150. Okay. And then you add a 64. This is an 8 by 8. And then you get 204. So your answer for number 8 is 204. I mean, for number 7 is 204. For shape 8 is 204, the volume. Question 8. Suppose the entire exterior of shape 8 is covered with paint. If shape 8 is broken into unit cubes, compute the ratio of the number of cubes with exactly 1 painted face to the number of cubes with exactly 2 painted face. Okay, we're going to split this into parts. So we're first going to find the number of 1 painted face, and then the amount of 2 painted face. Okay, for the number of 1 painted face, if you kind of look at shape 1, shape 2, and shape 3, I mean just shape 3, if you look at it, none of the top portion, none of these face shapes right here could count as 1. Because if you think about it, it's just all the top one is always going to be covered. Anything for these 3, right, for the second row, it's always going to be like a corner and then like basically another corner, a side corner, it's a actual corner, and another side corner, and then a side corner and an edge, a side corner. I mean, for the third one, it's a side corner, an edge, which is going to be 2, and then or 3, and then a corner, and then the side edge and a side corner. So basically, a side corner will always probably have like a 3, and a actual corner would have like 3 or like 3 to 5. And the top one will always have 5, while the edges will have like 2 or 3, basically. So you can't, so none of them have 1. So the only ones that you could look at is, since this covers the top, the left, and the right, if you kind of think about it, because you already look at the top and the bottom, you're just looking at, like, at this, face, looking at right now. You're looking at the top, the right, and the left. So now we just gotta look at the bottom, the left, at the back left, and the back right. So let's look at the bottom first. The bottom is the easiest. So you have a bottom, which is a square. Since it's shape 8, that means it's gonna be a 8 by 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So imagine, since you have these ones in the edges and corners, all these exterior don't work, right? Because like technically, if you have a corner right here, these 4 corners, they're all gonna have like at least 3 or like 3 to like basically 5. So all of them painted, so they're not gonna work. And then you're gonna have these ones. If you paint the entire one, since these are all clustered together, right? And they're only painting on the bottom, only these are the 1x1s. So since this is an 8x8 and this doesn't work, all the exterior doesn't work. So you just subtract 1 from the length and 1 from this length, which makes 8 minus 2 is 6. Subtract 1 from the width from here and 1 from the width here. That's 8 minus 2, which is 6. So the entire thing inside, which is basically any of these, right? Any of that, basically, it's just a 6 times a 6, which equals a 36. So right now we have 36 ones. And then now we're gonna count. So that's the bottom. Now we have to look for the right and the left. But technically, we only have to look at the right or the left. Only one of them, because if you think about it, they're kind of symmetrical. So whatever you get on the other one, on the right, you could just it's basically the same as the left, and vice versa. So whatever you get, if you get like 6, you could just multiply by 2, because they're basically the same thing. So we have if you're looking at the back left, 1, 2, 3, 4, 5, 6, and 7, and 8. So if you're looking at like the back left. So as I said, the corner pieces kind of don't work because like they're gonna be like 3 to 5, and the edge pieces kind of don't work also because they're gonna be like 2 to like 3-ish, if I don't remember. But basically the point is that it's gonna have something in like the like uh like if you spray paint like a face, right? Technically it has to be bunched up by a bunch of other cubes. So this cube is bunched up by this cube, this cube, this cube, and this cube. And it's already inside, like placed inside. So this is gonna be a 1x1. So you think about it, the only one that's a 1x1 is this one. That I painted once is this one, 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 and this one. You see it? Because it's basically all the ones that are not the exterior. Because since they're already inside, that means they're already counted. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 15. Since that's for the left, and I said it was symmetrical for the left, the back left and the back right, basically you just multiply that by 2, so that's 30. So remember we got 36 from the bottom? That means total together you have a 66. So the amount of ones you have is 66. Okay, so let's move to the 2. So for the 1s, you have the 66. So for 2s, since this is the back left, right? Imagine this is called the spine, right? So imagine, so you see 2x2, right? There's one in the back that's hidden. And then for 3, you have one here, and then there's one in the back that's hidden, and then another one in the back that's hidden that has a 3. Basically, that's what we're looking at. This is the, if you kind of like shift your, if you think about this shape, right? And you shift it like to the, you rotate it to like the right, you know, then you're looking at the spine. Then basically, since the 8 and the top one doesn't work and the bottom one doesn't work, then basically you just have to look at the ones in between. So there's 1, 2, 3, 4, 5, 6. So there's 6 already. And since you're already looking at the side here, right? There's technically the amount here, which is 1, 2, 3, 4, 5, 6. And there's also 6 here. This is a 2, which is just from the back left and the bottom. And if you have the right one, if you're looking at the back right, you're just going to have the back right and the bottom. So that's also 2. So there's 6 there, 6 here, and 6 here. So that's a total of 6 plus 6. 6 from the spine, 6 from the back left bottom, and 6 from the back right bottom. Because they're symmetrical. So technically there's 18 right here for the 2x2s. Okay? And and now if you're looking at the bottom, right? if you're looking at the bottom of this shape, which is the 8x8, square, none of them are gonna be a 2x2 because all the interior ones are the 1x1s as I shown before. But then all the corner ones are the ones that I said there are like 3 to 5, and the edges one are basically these edges right here, which is 1, 2, and 3. So none of those work. So but we don't have to worry at the bottom. Since this 18 counts for the back left and the back right, we don't have to look for those, so we already counted 3 of the sides. Now we just need to look for the top, the bottom, and the left, which is basically just looking at this way. So imagine like you basically make I'll just give you let's just draw this. It's not gonna be the best, but we have a 1, then we have a sorry about that. 2. I'm not gonna draw the entire thing. I'll draw a 4x4 because like that's basically all we need to think about this. And then we have this. And then 1, 2, 4. And basically like that. So the picture kind of looks bad, but this is basically a 4x4, right? If you think about it, the corner piece doesn't work here. The only one that's counted as 2 if you're pitting it is just this one and this one, right? If you think about it. Because like these already, all these on the like this side, kind of down, basically don't work. Because it already looks like it already have 3, right? So this one has 5, and this one has 3, this one has 3, this one has also 5, and all these, as I said before, since they're in the bottom one, which in our case, which is the 8x8, it will be like the top, the left, and the bottom, so that's 3, but it's always gonna be 3, so it's gonna be 3, 3, 3, all the bottom ones are 3, so they don't work, and the back of here don't work. These are corner pieces, the edge corners always never work, so, and this 1x1 would never work, basically. So starting with the 4x4, 2 of them works, right? Well, we're just gonna count one side, so ignore this one and say 1. And now, if you have a 5x5, right? If we're only focusing on one side because they're symmetrical, right? Because you have 1 here, you have 1 here. If you have 2 here, you also have 2 here. So we're just gonna focus on one side. So, and we can multiply by 2 to get the rest of the other ones. So if we have a 4x4, right? A shape 4, then we only have one that works. If we have a 5x5, right? And you add a 5x5 square on the bottom, then technically these two also work, right? Because basically you're gonna have the ones that the cubes on the bottom block up the painted on these. So only these two are shaded. So that adds another 2, so that's 3. And now if you have a 6x6, right? And you had like a 5 and then a 6x6, a 5x5 and a 6x6, that means those 3 from the 6x6, I mean from the 5x5, like right there, will kind of work. Sorry that I don't have enough room to draw it. But basically, you're gonna have one that's right here, one right here, and one right here, basically. But imagine that was the edge and you have it in another corner. Then basically another 3 is added, so that's 6. You see how the pattern's going? It's getting a 2 and then add a 3. So then a 7, you add a 4, which is a 10. And an 8, you add a 5, which is a 15. So since the left has 15, the right also has 15. So 15 plus 15 is 30. So you add a 30 here. So that covers everything. So this is the back left and the back right, and there's 0 for the bottom, and this is the 30 is from the top, the left, and the right. So you have a total of 48. That's 2. So now we can find the ratio. Okay. So the number of faces that painted only one side is 66, and the number of faces that painted two sides is 48. So the ratio is 66 divided by 48. Divide by 6 is 11. Divide by 6 is 8. So the answer is 11 over 8. For this contest, they said the real answer was 11 over 6, which they said there was 66 painted on the top, and they said there's 36 painted on the bottom. But what they really didn't account for is that when we drew our thing on the side, right? Remember that? There was a bottom row, and then there was 1, 2, 3, 4, 5, 6, 7, 8, right? They didn't count for these. So when we had the 18 and 30, for the 18 they only added 6 to get 36. They forgot the 12, which is from the back left and the back right for these things on the bottom. So they forgot those. But the real answer is 11 over 8. Okay. Number 9, the diagram to the right. WA is equal to 6, and AT is equal to 5, and and RE to ET is 3 to 2. What's the length of ET? So this is basically an inscribed angles and line question. There's a property that says the entire line, which is let's just choose one of the entire lines. So it's either WT or RT. It doesn't matter. We say WT multiplied by AT, the smaller version of that line, but still on that line, is equal to the other larger line, which is RT, times the smaller the other line, which is ET. So that's a property that's true. So if WA is 11 and WA is 6 and AT is 5, that means WT is 11 times AT, which is 5, is equal to RE plus ET, which is 5x. We have x. We just need to find out what scale times ET. So ET is 2x. So that gets a 55 is equal to 10x squared. And dividing by that, that's 5. 55 divided by 5 is 11, and 5 is 2. So you have x squared. So this one will be square root 22 all over 2 is equal to x. So what is ET? ET is just 2x. So multiply this by 2, and you get an answer of square root 22. Basically, just that simple. You just need to know your inscribed angle and lines properties. Diagram to the right for number 10. WA is equal to 14, AT is equal to 2, and ST is tangent to the circle. If the area of SAW, of triangle SAW, is 40, compute the area of SAW, compute the area of SAT. So, WA, SW, A, and AT, so that's what we got, and we got ST, is tangent to the circle, and SAW is 40, and we have SAT. So this is actually really simple. Let me just draw this out and get just some important properties. So you have this line here, and you have this line, and you have basically the point here, point here, point here, and we just draw a line here. Okay, and then we draw a line here because that's the. So they said this area was 40, and they said WA is 14, and AT is 2, right? This is just a similar triangle because think about it. They had technically the same same height, so the area would just be like in proportion. So if this is 14, that means this area right here has to be 7 times less than it because 2 is 7 times less than 14. The area of SAT is just 40 divided by 7 because 7 times less. So that's basically just it. That well, it's not 7 times less, but you get the point. It's just 40 divided by 7. It's basically just that simple. It's not even a property with like the circle. If you just have like a random triangle, right, and you put a point anywhere, and you say this area is like 30, and this is like 5, and this is 2, then you just divide the answer by like, actually, let's say this is 6 and this is 2, right? Then this area, x versus 30 would just be 2 to a 6. So you have to divide by 3, so x is just 10. So it's basically just like that. That's all you have to do. Number 11. Two circles intersect at points A and B. The radii of the circles are 5 and square root 17. The distance between their center is 4. Find the length of AB. So let's kind of draw this out. So we gotta think about this first. Because they said the circles are radius 5 and 15, right? and the distance between their center is 4. So if you have something with radius 5, right? Right, radius 5, and its distance 4, that means basically the line. Let's just say the center is basically right here, basically. So they're gonna intersect, and that's square root 17. Square root 17 is really close to square root 16, and square root 16 is basically just 4. So if that's 4, then basically, this distance is 4, it's gonna have something like right here, basically. So you have something like this as the distance. So the distance is 4, and then you have 1 here, and then this is square root 17, but the distance is 4. So this line is right here is square root 17 minus 4. That distance, that small distance, basically. So basically now we just have to get the line. This is a really bad picture. Let me just redraw this. So a little bit more. I'm just trying to get a clear picture for you guys. So like right here, right here. Yeah, sure, it's close enough. So the point is that it's right here and it's between them. And then you have a circle that's right there, right? So this thing is length 4. This is 1, and this one I said was square root 17 minus 4. Okay. And you had to find the length of AB. And AB would technically be a height. If you kind of think about it, it will always be a height. So what was the question? Find the length of chord AB. So technically, since this is like basically the same thing, so this side would be the same as this side. So what we just need to do is that we just find one of the length and then multiply the 2 to get the entire length. So this is pretty simple. We just have something like this. We make a line right here, make a line right here. Since we know it's a radius, and we just need to find the height basically, and there's a distance of 4 between them. So we just do some like system equations kind of thing. So if we label the height as h, okay, the height is h that we want to find, and since this is distance is 4, right? We could just call this x, and we could call this 4 minus x, because basically it has to have a total distance of 4. So what it tells us that if we're using this line with radius of 5, it says x squared plus h squared is equal to 5 squared, right? Because you just use the right triangle. So you use the right triangle here and make this line. So x squared plus h squared is equal to the hypotenuse squared. And then you have this one, which is 4 minus x squared plus h squared for this kind of triangle right here. Oops, sorry. This triangle right here is equal to its hypotenuse squared, and its radius. To its radius squared. Its radius is square root 17, so the radius squared is just 17. 5 is just 25. So if you expand this out, this is basically just 16 minus 8x plus x squared, right? So if you multiply the second equation, so no, actually let's simplify this so you negative 8x plus x squared plus h squared. Actually, let's write this a little smaller. I need some room. So yeah, negative 8x plus x squared plus h squared. 17 minus 16 is 1. And you have x squared plus h squared is equal to 25, right? So multiply this equation by negative 1, and then add to the other one, so 8x. That would be negative x squared, and that would be negative h squared, and that would be negative 1, so adding them together would just 8x equal to 24. So x is equal to 3, basically. So using that idea, we have x is equal to 3, and the height is 5, right? As I said before, so you could substitute x get back in to get h. So 3 squared plus h squared is equal to 5 squared. 5 squared is 25, 3 squared is 9, so 25 minus 9 is 16. So h squared is equal to 16, so h is equal to 4. So if the height of of half of it from A to basically where it intersects with the distance of the center is perpendicular, which is 4, then basically then which is half, as I said, was symmetrical, then just multiply 2 to get the answer. So 4 times 2 is equal to 8. So the answer is just 8. So based on that diagram, because what we do is that we just got the distance between them, and then you have x. You split them into length x and 4 minus x, because the line from A, B is perpendicular. And then you could just set its height, and then you make a substitute equation using the Pythagorean theorem. And you solve for x, and then you solve for h, and then you multiply the h by 2 to get the entire length of AB. Okay? Question 12. A spherical scoop of ice cream is placed into a empty waffle cone with the same radius as the sphere. The ice cream melts and fills exactly half of the cone's volume. What is the ratio of the cone's radius to its height? So the volume of a cone, of a sphere, is 4/3 pi radius cubed. And a volume of a cone is 1/3 pi radius squared. Since they're the same radius, it's basically the same times height, right? And they said that when the entire sphere melts, it's gonna cover half of the basically the cone. So basically so we say this is S, and this is the cone, which is C. So sphere and cone. So 2 of the sphere will make up basically the cone, right? That makes sense? So that basically says 8/3 of pi radius cubed is equal to 1/3 of pi radius squared times height. So if you think about, if you kind of like divide by the pi and the radius squared out, and you get 8 uh radius times 8/3 equals to 1/3 of h. So what's the ratio of the cone's radius to the height? So r divided by h. So if h is going to the left side, then you just put 8/3 on the right side. So it's 1/3 divided by 8/3, which is the same thing as saying multiplied by 3/8, which is the same thing as saying 1/8. So the answer is 1/8. Question 13. In triangle DRY, angle R is 90 degrees and DR is 60 degrees. How many different triangles are there such that tangent D is a rational number and DY and RY are integers? So we have a triangle. And we have DR and Y. And DR is 60. Let's say RY is 60, and we say dy is x plus a. RY is x, and dy is x plus a. Because if x is an integer, right, and a is an integer, then basically x plus a is an integer. So the hypotenuse is an integer, and ry is going to be an integer. So basically, it's using the Pythagorean theorem, because this is a right triangle, we have 60 squared plus x squared is equal to x plus a squared, which factors out to x squared plus 2ax plus x plus a squared. So the x squared kind of cancel each other's out. So we have 60 squared, because we want it to be just equal to x. 60 squared minus a squared divided by 2a is equal to x, basically. So if a is an integer, right, then if a is an integer and we plug in a into this operation, and if x comes out as an integer, then it's got to be a different triangle. Because like think about it, if like a is the difference between the number of units, that's the difference between the side length and like x. Because imagine one of them, which is 11, 60, and 61. So x in this case would be 11, and x plus a would be 60, and the difference between them is 50. So technically they're gonna be different numbers. Or if you have something like which is like a 60, an 80, and 100, right? So the difference between them is 20. They're always going to be a different number difference between them. Because if it's not, then basically it's because basically there's gotta be like different numbers. I don't know how to explain it, but basically they are. So using this idea, we just plug in different numbers for a and like count the amount of like outputs that are basically integers, and we'll get the answer. So the a can only go from the integer values like 1, 2, 3, 4, 5, etc. only from 1 to 59, basically. Because if a is 0, that means x side length is equal to the hypotenuse, which is not true. And if it's a is 60, then it's just gonna be 0, which doesn't work. Because you can't have a 60-60, because that's an isosceles right. And that's never gonna be a have a integer like hypotenuse. So plugging in the values for a could be 2, it could be 4, it could be 6, it could be 8, it could be 10, it could be 12, it could be 18, it could be 20, it could be 24, 30, 36, 40, and 50. And that's basically it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the answer is 13. For the answer key, they say it's 12, but basically the number they're missing is this one. They're missing the 10. So, like, the answer key says the answer is 12, but the answer is actually 13. Number 14, a two-digit integer n chosen at random such that it's 100 to a 999, basically. What's the probability that the three-digit of n form the side length of a cube triangle? So, how this works is basically, if you had three side lengths a, b, and c, where a and b is less than c because c is the largest side length, then a squared plus b squared has to be greater than c squared. That's basically for it to be acute. So, since we're just gonna look for c, we could just find combinations for a and b that work. So if C is 1, that means A and B could only be 1 and 1. Because it can't be 0, but if that's a 0, it's not going to be a side length. So it's going to be 1, 1, 1, which is the only possible, because A and B has to be less than C. So, less than or equal to C. So it's going to be a 1, 1, 1 would be an equilateral triangle. So for when C is equal to 1, there's only one possible triangle. So you have a 1, 1, 1. So when it's 1, it only has 1. So when C is equal to 2, right? That would equal to 4. So, 2. The only way would be 1 and 2, or 2 and 2, right? Or you could have 2 and 1. So basically, 2, 1, and 2. Because you could, like, but basically this is the same idea. Because if because this is gonna be a integer, so you can have 1, 2, 2. You have 212, or you can have 221. But you just need those three numbers, or you can have 222. So there's actually 4 ways you could do this. So there's 4, 3. So when C is 3, that would be 9. You have 1, 3. You have 2, 3. And you can have 3, 3. You can't have 2, 2, because that would make 4 and 4, that's 8, and this is 9, so that doesn't work. So other than that, like, all these are the only possible that that actually work. So we have you have 133, 313, or 331. You know, it's the same concept. So this would have 6 ways. I mean, this would have 3 ways. This would have 3 ways. There's a 1 way. So that's 7 ways. And now you have 4. 4 is 16. You have 1, 4. Oops, sorry. You have 1, 4, and 4. Or you can have 2, 4, and 4. Or you can have 3, 4, and 4. Or you can have 4, 4, and 4. Or you can have uh if this was a 3 and that's a 4, that's 16 and that's 9, so that's a 7. So for it to be greater than 7, you have to have a 3. So that'll be 9, that's 18. Yep. And can it be, and it could be can it be a 2? Because 2, that would be 4, that's 12, which doesn't work because next highest is 3, which is 9, so that doesn't work. So out of the entire ways, you only have, this one has 4, this one has 3 ways, this one has 3 ways, this one has 3 ways, this has 1 way, and this has 3 ways. So you have 3, 6, 9, 12, and 13. So you have 13 for 4. Okay, when it's 5, that's 25. So you have 1, 5, 5, 2, 5, 5, 3, 5, 5, 4, 5, 5, 5, 5, 5. And now you just have to find the ones that are like different. So let's say when it's 4, so that's 16. So you got 3, 4, 5. 3, 4, 5 is gonna be a right triangle because it's the Pythagorean theorem. So Pythagorean triple. So just have one higher, so 4, 4, 5, 4, 4, 5, right? And you can have any numbers below that. So basically, you're gonna have. Actually, you can have a. No, you can't. So you can have a 3. So if 5 is a 3, it's already 3, 4, 5, so you can't have that. So basically, you have 3 here, 3 here, 3 here, 3 here, 1 here, and 3 here. So you have 3, 6, 9, 12, 15, 16. So 5 has 16. And if you have 6, if C is 6, then we have 1, 6, 6, 2, 6, 6, 3, 6, 6, 4, 6, 6, 5, 6, 6, and 6, 6, 6. 6, if you have a 5, 5 plus 5 squared and 5 squared is 25 squared. So you have a 5. Can it be 4? That would be 16, and that will be 25. So that's 41. So 4, 5, 6 works. That would be 9, and that would be 34, which is not, it can't work. So if we have a 4, the next highest would be a 4. So a 4 and a 4, that's 16, that's 32. So no, it can't work. So this would be the smallest one that it can actually start working with. So this one has 3 ways, this one has 3, this one has 3, this one has 3, this one has 3, this has 1. This is 5, 5, 1, 6, so this has 3. And this one has 6 ways because it's 4, 5, 6. There's 3 different numbers. So that's 3, 6, 9, 12, 15, 18, and that's 24, and that's 25. So we have 25 ways for this one. Okay. And now 7. So as I said before, we don't really have to write this out the entire time, so it's 177 all the way up to 777. And then we can have, if we have a 6 and a 7, 6 and 6, that's 36, that's 72, which is greater than 49. Or 6 and 5, which would be 36, plus 21, which is 61. 36 and 25, which is 61, which is greater than 49. 4 and 6 and 7, that's 24, that's 36, that's 60, that's greater than that one. 3, 6, and 7, that could be 36, that's 9, that's 45, so that does not work because that's 49. So the next number, let's say 5. That's 25, so 5, 25, 25, 50. So this is basically the smallest number it could work with, because if you put a 4, then the next highest is 32, so you can't, so it doesn't work. So since 177 to 677 is like 3 ways each, that means there's 18 ways for those, plus the 1 there. And then you have 3 here, 3, you have 3 here, 6 here, 3 here, and no, you have 6 here, 6 here, and also 3 there. So that's 6 plus 6 plus another 6, so that's 18. So that's 36, and that's 37. So 7 is 37. Oops. Delete this. Seven is equal to 37. What was 16 again? 16 was 166 to 666. And you have 1, 5, 6. You got 5. 4, 5, 6. 3, that's 9. That's 25. That's 34. Nope. 4, 4, 6. Nope. So that's all. So you have 3 times 5, which is 15. Plus the 1, plus the 3 here, and plus the 6. So this was 9, that's 10, that's 25. Okay, there was 25. Okay. And now when C is 8, this one's just really tedious. You just have to do a lot of work. So as I said before, the 1, 8, and 8. But that's all the way up to the 8, 8, 8, etc. Basically. And now you could do with the 7 and 8s. So that's 64, that's 49. So you could probably put a 7 here, and it'll be safe. So how many can this go up to? This 7, 8. So you could have 64 minus the 49, which is 15. And the highest number greater than this one is 4. So go down to 4. Now you have 8 and a 6. That's 64 minus 36, which is 28. And the highest number bigger than that is 6. So it can only go up to 6. So if it has a 5 and 5, that's 25, and that's not greater than that. So from here to here, there's 7 ones that repeat, like 7, 8, 8, 1, 8, 8, 2, 8, 8, 3, 8. So there's 3 ways for each for those. So times 7. So 3 times 7 plus the 1 because of 8, 8, 8. So you have 22 so far. And then 788 always 788 will just add an extra 3. And then there will be a 6 and a 5 and the 4. The 6 and the 5 and the 4 all are different. So you add a 6 each for those 3, so that's 18. And then you have a 688, which is just another 3. So you have 22 plus 3 plus 18 plus 3, which is 46. Okay. $46. And you have 9 here. So the last one is 9. So as I said before, 199 all the way up to 999. And then you have 8 and 9. So what number from there? So that's 81 minus 72, which is basically a 9, so that's square roots to a 3. Wait. 81. Oh wait, no, 81 minus 64. Sorry about that. Which is 17. So the next highest is a 5. So it can only go up to 5. So this got 8. So it can only go up to 5. Go down to 5, 9. 5, 8, 9. And then you have a 7, 9. So that's 81 minus 49. And the next highest is 6. So you can only have 7, 7, 9, or 6, 7, 9. And then if it's a 6, that's 81 minus 36. And it has to have a 7. So we can't work with those. So that's the smallest. So there's 8 numbers that have 3, so 8 times 3, plus the 999, which is the extra 1. And then you have 8, 8, and 9, which is a 3. And then the 7, like it starts at 8, so it's gonna be 7, 6, and 5. All those 3 has 6. So 3 times 6. Plus 777, which is a 3, because there's 3 ways to write it: 779, or 797, or 977. And then there's 6 ways to write 697. It's 3 different numbers. So you have 6 of those. And that gets you 55. So, facing the rest of this, we got 55. Okay, we don't have to clean everything. Okay, that's 55. So adding that together, 1 plus 4 plus 7 plus 13 plus 16 plus 25 plus 37 plus 46 plus 55 gets you 204. And of the 204, how many numbers are between 100 and 999? So that's basically 999 minus 99, which is 900. 204 divided by 900 is 17 all over 75. So that's the answer for number 14. Number 15, in the right rectangular prism to the right, the sum of the length, width, and height is 23. If the surface area of is 312, what's the length of AG? So they're looking for the 3D diagonal. So the space diagonal, or whatever it's referred to. So the sum of the length, width, and height is 23. So length plus width plus height is 23. And they said that the surface area which is just 2 length width plus 2 width height plus length height. Just put 2 length height plus 2 width height is equal to 312. So AG is calculated by saying L squared plus W squared plus H squared, and then square root the entire thing. So basically what we're do is we're just gonna have L plus W plus H squared, which kind of gets out to basically L squared plus 2LW plus 2LH plus W squared plus 2 plus LW plus LW, yeah, plus 2WH plus H squared. So that's what it expands out to. So you only need, so you get the LH squared, right? The W squared and the H squared, and you get the extra 2LW, 2LH, and 2WH, right? So we just need to subtract that out. So 2 L plus the length plus the width plus the height squared minus the 312, because that's the 2L, the 2 length times width plus 2 length times height plus 2 width times height. Square root is the same thing as saying 2 length squared plus width squared plus height squared. So using that, 1 plus width, length plus width plus height is 23. So using that, that's 23 squared minus 312 is square root 217, which is equal to just square root 217. You can't factor this, so that's your answer, square root 217. That's an easier way to do it, or you could just like choose some random numbers and you can start testing. But that's usually how I do it. I just manipulate the variables around. If I see something like length squared plus width squared plus height squared, I usually just make it all into parentheses and try to like use that to its power. So if it was length cubed plus W cubed plus height cubed, I just put L W plus H cubed and then find out what it factors out to, and I subtract everything until I get only these terms basically. Question 16. In the right rectangular prism to the right, S is on DH such that DS to SH is 1 to 2, and S is on TE. Okay, so it's on the bottom square. So let's kind of draw that out. So you have D, H, E, and A. And they say S is right here, and T is right here. And it's in ratio 1 to 2, and this ratio is in 2 to 3. So we have S, or M is a point on B, C, G, F. Okay, so the point is on the top of the face, so we're gonna make a prism. Compute the ratio of the volume of the pyramid STEAM to the volume of the rectangular prism. So STEA and M is on top, so you're making this shape. So we need to find the area of this. Because basically what we had to do is find the volume, is that we're gonna have to find the ratio of the base times basically the general idea of the the pyramid. So this is 2. So this is 2/3 because 2 plus 1 is 3, so that's 2/3. And that's 2 and 5, so 2 and 3, so that makes 5, so that's 2/5 because I was looking for this area. And then times a half because it's a triangle, so that's cancel out to 2, so that's 2/15. So this one is 2/15. And this one is 1 out of 3. This contains the entire length, so it's just 1/3 times the triangle, which is times a half, so that's 1/6. So this one is 1/6. Okay. So 2/15 plus 1/6 is 3/10. So the area of that base is actually 7/10. So the base ratio is 7/10 versus the original one. Because the volume, you're gonna be out of 1 anyway, so you don't have to do too much about it. Since the rectangle is just length times width times height, and a prism is just like length times width times height times 1/3, just multiply that base ratio by 1/3, which is gonna get 70 out of 30, and this should be the volume ratio, the volume ratio. So the area, I mean, for the answer for 16 is 7 out of 30. Number 17. A cube is rectified when the midpoints of each of the edges are connected to the adjacent midpoints to form the face of a new polyhedron. Compute the number of faces, edges, and vertices of the rectified cube. Give your answer to the order pair of faces, edges, and vertices. 1, 2, 3, 4. 1, 2. And basically just make the points. And then point here, point here, point here. Then when you have this point go here, you ever connect this one, got this one. Oh, okay. So, oops. We only got 1 point here. These points are here, which connects these points. And this point is this point. This point is right here. So it's 1, 2, 3, 4, 5, 6, 7. Wait, 2, 4, 6, 8, 10, 12. Yeah. So basically, just think about how it connects. So now when you connect the let's find the number of faces, edges, and then vertices. So the number of faces, we connect the adjacent vertices. You have here, and these connect to this. This connects to this. Connects to this. And then this connects to this one over here. And it connects to this one over here. This one over here. And there should be... It connects to this one, and oops, sorry, it doesn't connect to that one. It connects to only these two. And this one connects to this one over here. Connects to these two, connects to these two, and this one connects to those two, and this one, and this one. And this one connects to... It's on the... Sorry, I'm trying to think about how this looks. Actually, instead of putting this point here, I should put this point right here. Okay, so it's more balanced. Okay, so based on that, we can make one right here. 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 Oh, I forgot a point. Wait, no, I didn't. Did I? No, yeah, I did. I forgot a point here. So that's 2, 4, 6, 8, 10, 12. Yeah, that's 12. And then these 2 points are connected. Actually, let's just use a different color. It'll be better. But we have a face here. We have a face here. We have a face here. This one connects to this, and this. So This one connects these. And this one, if it's on the side, it would technically connect to this one. And it'll connect to this one. And there's one that's bottom, so it connects to that one all the way over there. Actually, no. It would connect to this one and then these two on the side, which is, wait, 2, 4, 6, 8, 10, 12. Yeah, so it'll be right here, connects to those, and connects to these two on the bottom, which is these two. So right here, like that. If you put them together, based on like how you think of 3D. So each of these points should have like 4 connections to each other point. So this one should have, this one I already have 4. This one has 4. This one has 4. This one has 4. This has 1, 2, 3. So connection. This one also connects to right here. This one also connects to right here, basically. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. This is the 3 right here. Then you have the fourth related here. Then 1, 2, 3 here. So you have a 4 right here. And this one has 1, 2, 3, 4. So yeah. So basically counting the amount of faces, which is 1, 2, 3, 4, 5, 6, 7, and then basically 8, 9. Wait, 1, 2, 3, 4, 5, 6, 7, and 8, 9. This basically makes 10, 11, 12, and 13. And then, yeah, 13. Because that's on the side. And then remember, there is ones on the bottom. So there's an extra one on the bottom. Then that makes 14. So there's 14 bases. Since this is looking at 2D, you're looking at basically the top. Because there's also one at the bottom. So you have to account for that one too if you think about it in 3D. So that's why it looks a little, why you can't get the 14. Because it's all the way in the bottom. So that's the disadvantage of using a 2D model. But it's easier to think about. You just count all the places where it has like the basically an area. And now we just need to count the number of edges. I don't know, I erased it. Why did I erase it? Oops, no. Then connect these. And these two are connected, I think. Yes. And these two are connected. These two are connected. And 1, 2, 3. These two are connected right here. So this was the one, yeah, this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, yeah. So counting the amount of basically the edges now. So we have 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So we have 24 edges. So far we have 14 faces, 24 edges, and now we just need to get the vertices. So vertices are basically just the intersections. So think about it. Since you only have 12 points, that means you're also just gonna have like, because you have 12 sides, right? And every single side has a midpoint, and those points are the ones that you're connecting. So the ones that you're connecting are basically the vertices. So it's just basically just 12. So So that's your answer, 14, 24, and 12. One way to check that you're right is that there's something called Euler's number or Euler's formula. I'm not exactly sure for polyhedras. They basically say that the number of faces plus the vertices minus the edges should always equal 2. So four, so 14 plus 12 is 26 minus 24 is 2, which is true. Or you can have it has the same thing. Like a cube is a polyhedra and has six faces. Its vertices are 8, and its edges are 12. So that's 14 minus 12, which is 2. Or you have a tetrahedral, which has 1, 2, 3, 4 vertices, 4 faces, and its edges are 1, 2, 3, and 6, which is 8, and minus 2 is 12. So always follow this formula. So this has to be true. 14, 24, 12. Question 18. A circle is inscribed inside a triangle with a side length 25, 39, 40. Compute the area of the inscribed circle. Okay, for inscribed circle, well, the basic idea is that there's two kind of circles. There's inscribed circles and there's circumscribed circles. Circumscribed circles go through every single like vertice, and inscribed circle goes through like touches a point only one point at every single line basically. So they said inscribed, so the circle is gonna be inscribed a triangle. So basically, there's a formula for it to find the radius. It's called the in radius. A circumscribed circle is called the circumradius. So for the in radius, it's basically calculated by the area, 2 times the area, divided by the perimeter. So to get the area, another thing you're gonna use is called the Heron's formula, which basically is that you just use your calculator, just follow along. It's just add all the side lengths together to get the perimeter. So it's 25 plus 39 plus 40, and then divide by 2 to get the semi-perimeter. So you have square root 52. Write that down first. And then you have 52 minus the 25. And then you have 52 minus the 39. And then you're going to have 52 minus the 40. So you basically have the semi-perimeter multiplied by the semi-perimeter minus multiplied by every single number minus the. So you have the semi-perimeter multiplied by each of the numbers that is basically the semi-perimeter minus the side lengths. And then you square root them all and you get the area. So that is 52 times 27 times 13 times 12. And then you square root it, and you get 468 as your area. Your area is 468. It's basically just that simple if you're a calculator. So 2 times 468 divided by the perimeter. The perimeter is 25 plus 39 plus 40 is 104. Okay. So 468 divided by 104 times 2 is 9. So the in radius is length 9. So the area is just pi radius squared, so it's just 81 pi. Basically, that's simple. Okay. Now, question 19. Let t is 0, 0. Let's draw this out. 0, 0. 4, 0 is r. So t, r. There's a 4 between. 2, 3 is a. So 2 and 3 up. It's a. Okay. And 0, 3 is p. 3. Okay. So quadrilateral TRAP is revolve around the y-axis. So it's gonna go around here, 360 basically. Compute the surface area of the resulting solid. So basically, you're gonna when it goes around, it's gonna make like a kind of like a cone. So it's supposed to be a triangle, and then it makes like a cone, and then you could subtract this triangle out. This cone part when this cone goes around, it makes another cone, a smart cone, and you subtract that out. Basically, you're supposed to get the surface area of the resulting. So you have to get the area of this space plus the area of this space plus this entire basically surface area. So the surface area of a cone is 1/3 pi radius what no, it's pi radius squared plus pi radius slant height. You know, this is the slant height. Um, so basically, using that idea, we have um 16 here. So that's 16 pi because it's gonna revolve around its radius 4. Plus pi, the radius is 4. And the slant height of this, we're not exactly sure. But basically, we're just gonna have to make a triangle all the way up. So this one's at 2 because it says it's 2, 3. So it's 2, 3 up. So if this is 2 and this is 4, then basically using basically this is gonna be, this is x, then it's x plus 3 divided by 4 is equal to 2 over 4. I mean x over 2. So multiply by 2, so 2x is equal to x plus 3. So x is just equal to 3. Which makes sense because it's just supposed to be double. So x is equal to 3. So that's 3 over 2 over 6 over 4, which is also just 3 over 2. So using this idea, this one's also the one for this one is the new radius. So it's gonna be 4 pi plus which is, this is 2, 3, and this one is gonna, so having that is 6, 6 and 4. You have to get the slant height, which is the hypotenuse. So 6 squared plus 4 squared is square root 52. So square root 52 for this one. And then for this smaller one, it's just 2 squared plus 3 squared, which is just square root 13. So it's, so this entire, so the volume for this is pi radius, which is 2 square root 13, and this one is 2, 4 square root 52. So since basically we have this base, which is just this base, which is what we're gonna add. So we have pi over 4, which we need to add, pi over 16 for the bottom base, and we need the lateral surface area, but it's pi 2 pi 16. I mean pi 2 pi, yeah, square root 13, and 4 pi square root 52. So you just have to subtract those. 4 square root 52 is the same thing as 2 square root 13. So this is just 8 square root 13. So 8 square root 13 minus 2 square root 13 is 6 square root 13. So this is 6 square root 13 pi. So adding them all together, you basically just have 20 pi plus so 4 plus 16 is 20 pi plus 16 square root 13 pi. So that's your answer. 20 pi plus 16 square root 3 pi. 20. Given a regular polygon with 216 sides, compute the number of diagonals such that there are at least 3 vertices separating the endpoints of each diagonal. Okay, the general idea for finding the total amount of diagonals is x, which is the number of side lengths, times x minus 3 divided by 2. The reason that this is a 3 is that if you're drawing a polygon, right? Let's say just like a pentagon, right? You have a 5, right? If you're using this point, you can't use this point to make a diagonal because it's side length. You can't use this point because it's gonna have a diagonal. I mean, it's gonna be a side length also, right? And you can't use this point because that's the point. That's the original point. So other than that, you have to subtract 3 points away, and you could use the other points. So that's what the general idea is. So if you have, so if you're using 260 sides and this compute the number of diagonals with at least 3 separating them, then basically you're doing 1, 2, 3, 4. 1, 2, 4. If you're using this point, you can't use these 3s, and you have to have here, and you have these 3s separating here. So you can't use 1, 2, 3, 4, 5, 6, including the point they're using, which is 7. So that's total 7. So the formula would now, instead of 216 times x minus 3 is x minus 7. So it's 217 minus 7. So it's 2009 divided by 2. So using that, the answer is 216 times 209 divided by 2, which is 2025072. Sorry, I'm 2025072. So So that's your answer, 2,025,072. Well, that completes everything for the CCML Geometry Contest 5 2015-2016 Division A. Thanks for watching, and I'll see you at the next math record.